All right, well, welcome to this meeting about FairCom DB. FairCom DB has a new version that unlocks some new features that are unique in the industry and will, I believe, change a lot of applications for the better and give you the ability to create applications at lower cost, genuinely lower cost, and with more capabilities than ever before. Because we've introduced a new feature to FairCom DB that is event streaming. Event streaming is a feature that combines message queue operations where you can send messages, you can push messages, subscribe to messages, and all those messages are automatically stored in the database as an event log. And then you can come back in your application and read the event log and get all the messages. In addition, that's the event streaming. In addition, we've got JSON DB capabilities in the product. Everything is managed through JSON. We'll show you how that works in the demo with the event streaming. And we have SQL in the database. So we are a combination of event streaming, JSON, and SQL, all in the same database. And for those of you who are familiar with Firebase, Firebase would be sort of similar to our database, except for our database is more capable because we have the SQL, we have the full JSON, and we have a more powerful event streaming engine, more similar to Kafka. So you could kind of think of FairCom DB as a Kafka combined with the SQL database, combined with the JSON database, like Mongo and SQL Server and Kafka, all in one engine, um, all at the same time. So over the same data, you can do event streaming, SQL, and JSON, and mix the two together in really interesting combinations. So if you're, for example, if you were building an application that was like Slack, if I were building Slack today or wanted to compete with Slack, I would use the FairCom DB without a single question, because you can do everything Slack does with one database, super fast and easy. And so imagine Slack where you're pushing messages, where you're searching and finding historical messages, where you're keeping to-do notes and all the things you can do in Slack. The FairCom DB can do very well for you. So you just have one solution that solves all your database problems. So I'm going to jump right into some event streaming capabilities that are built right into the product. So I'm going to jump to our MQ Explorer. MQ Explorer is a message queue engine that's built into the database. And it's not just an open source third-party MQTT broker that we just patched into the system. We built this, and we built it into the database. Or you can even reverse that and say we built the database into it. Either way, they're the same thing. It's not two products, it's one product in the one. So we have a dashboard for all that. You can see who's connected. You can diagnose and troubleshoot and drill into all things MQTT. I'm going to now go to another feature, which is simple pub sub. This application can do publications and subscriptions. Now it's using event streaming technology, which is typically uses WebSockets. WebSockets is a technology that's asynchronous, allows a browser application like this MQ Explorer to connect to the database so it can receive push events from the database. So it can push messages to the database, and this database can push messages to it asynchronously. So now I'm going to demo how you can publish a message to the FairCom DB. And as soon as you publish the message, it ends up in the database, and it also ends up published to all the subscribers. So I previously subscribed to API World. You can see the subscription here, API World. Now I'm going to publish a message to it. It's going to say, hi, everyone. Welcome to FairCom's booth at API World. We'll publish that message. And there you saw it come in right away, because event streaming is very quick. You're publishing and subscribing over WebSocket in the browser. I'm now going to shift over here to the MQTT Explorer application. And this is a third-party tool. It has nothing to do with FairCom. And I subscribe to the API World topic, and you can see this message coming in. Hello, everyone. Welcome to FairCom's booth at API World. So if I just publish another message real fast, you'll see it come over live, published to both places. Let's see if I can pull off that little demo. We show both screens at once. Let's publish another message. Let's just say FairCom DB is event streaming, JSON, and SQL at the same time on the same data. Let's publish that message. You saw it pop in over here underneath, and it should have come in over here in the MQTT Explorer, because you can have hundreds, thousands of subscribers, and because it's a push technology, FairCom DB will push that information out to all the subscribers at the same time with very low latency, very high performance. Now the trick is, because it's event streaming means that we have a log of all the events. So we've had messaging for a long time and a lot of products. Message queues are all over the place. You could buy ActiveMQ or RabbitMQ. You could buy IBM MQ. All those products send messages. The problem with messages is that once the broker sends them, it forgets them. So it's a send and forget technology. And what if you want to know the event log so that a new application can start from the beginning and get all the messages? For example, what if the messages were data change messages of data that's changed over time? If you wanted to, you could replay a log and recreate all the data change events. Or what if you just want to get caught up on a lot of messages while you were gone? You want to replay messages. And so that's what makes the difference between a message queue broker and an event streaming platform. So FairCom DB includes a message queue broker, and it is an event streaming platform. So how is that? Well, I'm going to show you a tool called Edge Explorer, which comes with our product. It's another app. It's another user interface, browser-based user interface. It uses the FairCom JSON APIs and the SQL features and the broker features all at once to provide you with a view of an event streaming view of the data. So here are some messages that we've been sending over here at Event API World, and there's different people we've met at the World, and here we're going to see, there it is. You see the last messages? These came from the database. We're actually using our JSON API in this FairCom Edge Explorer to go query those data messages and display them. So here's the log of the messages that we just, as I did demos at API World, all the messages that we've been sending. So you can see the data in the database. So that's, and here is the table here, MQTT Message API World. And you can see it's an MQTT protocol, and it's the Message API World topic. So this is another view of the data. You can see the records here in our Data Explorer. Data Explorer is another browser-based application from FairCom. It uses our JSON APIs to go get its data. It's focused a lot on SQL. So I could even show you this thing. I'll just ad hoc do this, select all from MQTT Message API World, and run it. And there's the records. I use SQL to go query the event stream, which is really cool. It's just built into the product. And you can use SQL to filter the event stream. You can filter it by all kinds of criteria. The ID, by the time of day it was sent. You could filter ranges of time. You could go troubleshoot something and say, what if we had a problem last Thursday at 2 p.m.? We were missing some messages. You can go back and look at the event stream and see the messages you're missing. You could do that. You can do it over here in MQ Explorer, which is here, or you could do it over here in Data Explorer through SQL queries. You can even run SQL scripts and script activities. But I'm now going to shift over to our JSON API Explorer so that you can see the same thing. Now I'm just going to go query that same data. So let's go over to Get Records by Table. I'm going to change this table to the MQTT Message API World. I'm going to run this query. So I'm going to hit the Run button. And it comes back right off the bat at the end. There's always an error code you can check to see if it's a 0. 0 means it was successful. I'm going to scroll up here, and you can see these are the messages. So this message right here is one of the messages. That's the same data you just saw in the SQL. So this is the SQL view of that exact same data. This is the JSON view of that data. And over here in MQ Explorer, this is the MQ Explorer view of the same data. Same stuff, different views, because your application can use different technologies to get the same data at the same time, which is really cool. Think about that. Messaging data is now SQL and JSON data simultaneously. You don't have to even worry about it. You just use the APIs and get the data the way you like it. All right. I'm going to go show you how you can do a lot more than just do event streaming in the FairCom DB. I'm going to show you create a table and go through a whole process of managing all your data. And you can start at either end. You can start at the database end and create tables and put data in tables and then use them in event streaming and vice versa, because it works across the board. So let me go create a table. I'm going to create an athlete table. So here's an athlete table. See, it says the action is create table, and the table name is the athlete. Now, one thing to know about this JSON API, this JSON API is pure JSON, and you pass genuine JSON, or you post JSON to our endpoint. An endpoint is just listening on like if a browser URL, it would be just listening on localhost 8443/API. So you just post this JSON payload to that endpoint/API. Our database takes it. If it authorizes you, then it'll let you run these commands. So I'm going to run a command here to create a table called athlete. And then here I've got different fields. I've got a name field for the name of the athlete, the ranking. So I'm going to put the world's most famous athletes in this table. And so I'm going to put their ranking in the world based on how successful they were. And don't shoot me if you disagree. Like if Babe Ruth is more or less successful than Michael Jordan, and in your opinion, well, that's great. Let's have a debate after the meeting. But this is the internet's ranking of them, whatever that means. And here's birth date, player number, whether they lived past 2000 or not, a Boolean idea, and how much money they made. So let's see how much money Michael Jordan made. That's going to be fun. Their favorite saying, that kind of stuff. I'm going to add one more field to this that I don't normally have. So I'm going to show you how easy it is to just tweak this JSON. I'm going to copy this right here under name, and I'm going to put a new field in here. So the field's name is going to be my JSON field. It's very inventive. But maybe I'll get more inventive than that. I'll just say addresses. Okay, so I'm going to put addresses in here. I'm going to make it a JSON field, and we can have JSON fields that have up to 2 gigabytes of data in them, which is outrageous. But normally people have, a couple of K of data. So I'm going to put 65,500. So that's 6K of data. So it'll allow you to have a JSON document that's 6K in size, which is a really big JSON document. I'm going to go create this table, run it. It should come down here in the response, error code 0. That's a good sign. It said it worked. So now I'm going to refresh my list of tables over here. There's the athlete table. So now there's no records in the table so far, but you can see over here that there's a name, address, ranking, birth date. These are the fields in the table. I can go and let's go stick some records in them. First, though, I'm going to create some indexes before I put records in, because it's always nice to have indexes before you start inserting things. So I'm just going to create a couple of indexes. Notice this create index. I've got athlete. I'm going to name the index. I'm going to make the ranking field be the ranking, be the part of the index. Notice there's multiple fields. You can have multi-field indexes. We have a whole bunch of features on indexes that are really cool. I'm just going to create a real simple one here. So just run that. All right, no errors. So it worked. We created a ranking index. Now let me go down and create an earnings index. So we can sort athletes by earnings. We can query them by earnings. Same story, athlete, index name is earnings, field name is earnings, run the index. Now I'm going to do the same thing again for another index. This time it's a special index. It's a name lived past 2000 index, where I'm saying the index has a conditional expression in it. The athlete must live past year 2000 in order to be in the index. This is a special, super powerful feature of the FairCom database. You can build conditional indexes. So one of the secrets to performance is for a database to already know the answer to your question before you ask it. because then it has it all cached and ready to go, and it can give you the answer as fast as possible. That's the secret to programming in general, really. So what we do is you can create indexes, up to 2,500 indexes on a table. And you can pre-answer your biggest, most important questions in the index. Like, okay, I want to know all the athletes that live past 2000. I want to know the athletes that live past 2000 and made over $1 billion. And, and you can create all your conditions, create your indexes. And what happens, FairCom will keep all those indexes up to date when you insert, update, and delete records. Then when you want to go run a query, you can use this index in a query, and I'll show you that, and you'll get back the exact answers you want instantaneously. It's better than an Oracle materialized view. It's better than any other system in other databases for a couple of reasons. One is an index is very lightweight, doesn't take a lot of space on disk. Another reason is you can create the index to be deferred. So that means that when FairCom DB does an insert, it puts the index update operation or the insert operation into a queue, and then it automatically returns committed to you as soon as the record is inserted. So it doesn't wait for the index to be updated. So normally the problem is if you have lots of indexes, every index you add, it slows down inserts, updates, and deletes, and that's a problem. But especially if you had like 1,000 indexes. But if you make them deferred, then it doesn't slow down your insert, update, and deletes. They come back just as fast as normal. And then the database in the background will keep all the indexes up to date, but they're always up to date quickly. And so that way you can have answers to your questions updated quickly without slowing down your operations. That's a really cool feature. You can't do that in Oracle or SQL Server or MongoDB or Couchbase, but you can do it in FairCom, and it's really cool. And the other cool thing is you can't do it in like other key value systems like in Amazon, like DynamoDB. You can't do that deferred indexing trick. And DynamoDB, for example, is fast like FairCom DB is, but DynamoDB only runs in the cloud, for one. We run everywhere. The other thing is DynamoDB charges you for every secondary index you have. We don't charge you for our indexes. Dynamo charges you, if you have a secondary index, they charge you just as much as the primary database. So you have 4 of them, it's 4 times the cost. You can have 2,500 secondary indexes on FairCom DB, won't cost you any more money, hardly any extra storage, and you get way more performance and capability with very little cost. So this is one of our really cool secret sauces. And this is a deferred index. Well, it can be deferred, it's optional. This is a conditional index that you can defer so that it doesn't slow down your insert, updates, and deletes. So it's one of my favorite features. So I'll create this index. Came back with no errors. Now that I've got my indexes created, I still have no data. So let's go insert some data. So I'm going to go over here to the table, and I'm going to go insert records into athlete data, to athlete table. So here we go. I've got insert records. Here's my athlete table. And you can see I'm just inserting JSON objects. So a JSON object equals a record. So there's just a complete match between a JSON object and a record. So I'm going to go insert this data. No errors. So I'll come back over here to the table records, and I'll refresh it. Let's see. Oh, there they are. So I just ran a SQL query and got back SQL data from stuff I just inserted using JSON. So there's completely interoperable. I can edit the data here. I could say, okay, I think Wayne Gretzky really should be ranked higher, or I should say, no, goodness, I hate Canadians, which I don't. I love Canadians, but I could make them really bad ranking or something if I wanted to and save that record. I just updated the data using a SQL backend. I can run a SQL query on that data. So let's change this to athlete. So you can see SQL is actually running the query. Here it is. I can even put a where clause in the SQL and say, well, okay, where I love Canadians, which means where the ranking, I just changed that to be greater than 999, or his ranking 999. So I'm going to say greater than 99. And let's see what happens. Oh, there he is. Wayne Gretzky, great hockey player. So it's just normal SQL stuff, right? So now I'm going to go over to JSON. Can I query the data using JSON? Absolutely. I can use a JSON query to query the data in SQL or JSON or an event stream and get the data back as JSON. So let's do that. Let's get the data back as JSON. So let's go query. I want to change the name of the table from test1 to athlete. Just going to run it. This will give me all, this is get records by table. So it's going to return me all the records in a table. And of course, obviously, if you have too many records in a table, you might want to put some limits on this thing. But if you have 100,000 records, go right ahead, because as long as you can handle it, because we can handle it, and we will stream that 100,000 records to you so fast, it'll blow your client up. So just be ready for it, because we can really push some data at you. So here we go. This only has 6 records, so it's really easy to stream. So there you can see JSON data coming back out of the data. So it's simultaneously SQL data, JSON data. You can use SQL or JSON APIs. We automatically convert the data to be the right thing for the right API. So there is our data inserted into the athlete table. Let me show you a couple of cool things about our JSON API. We have built into the JSON API specific kinds of queries for high-speed queries. Now, this is really important, and this is part of FairCom DB's secret sauce. In a SQL database, all you get is SQL. Now, SQL is awesome. It is the most powerful query language ever created. The SQL engine is incredibly powerful. You can query anything in any table, in any field. You can, even if you never have an index on the field, you can just query it, you can sort it, you can filter it, you can join tables together, sort, query, filter, you can run aggregates on it. Incredibly powerful. But developers really assume that all that magic is magic, but it's not magic. Every time you say to a SQL database, hey, go join these tables, go run this sort, do this filter, the engine has to figure out, okay, how do I do that? So when it gets the SQL statement, it has to parse the SQL statement. Then it's got to go run to an optimizer. An optimizer goes, what's the best way to go run this SQL statement? I got to do 20 things or 30 things to make this thing happen. So it goes and figures out the best way. It looks up statistics on the tables. It says, oh yeah, if I do it by this table first, it'll be faster than if I do it by that table. And then it figures out a plan. So it figures out, how am I going to go pull this SQL statement off? Then it generates interpreted code to go run the plan. And some databases will even compile that code, and then it runs the code. Then it gets the data back, turns that data from binary data on disk into text data, sends it over the wire to you. Your client library has to read the text data and convert it into your binary data for your language, and then you're ready to go. Well, that's a lot of stuff. And so what happens is SQL queries have so many layers to go through. They're slower, and sometimes that optimizer gets it wrong. And I was an Oracle DBA for a number of years at a very large company, and I ended up managing the Oracle team. So I'm an Oracle expert, and we were called in constantly to go. And Oracle is the #1 database in the world for its optimizer, and but the thing gets it wrong all the time, and so you're called in to tune queries. So you come in there, and Oracle has these hints, and you can stick hints in there, say, no, don't do it in that order, do it in this order. I know better than you. And you have to spend hours and hours and hours tuning these SQL queries to make them work right. So that magic is not so magical. Just ask any developer who uses a SQL database. So what we did, we have all that. So FairCom DB has all that SQL engine and all the wonderful things it can do, and you need it. So don't get me wrong, just because I was being critical of the optimizer, it slows performance down, but you need that flexibility. If you're building a real-world application, you need the ability to do anything in your app. Because somebody's going to come to you and say, well, did you think of this? Hey, some guys go, can you get me a report that filters this way? Oh, can you give me an online screen that has just this data on it? Oh, crap, I didn't think of that. Oh, no. In SQL, it doesn't matter. You can write the query, get the job done, and make your customer happy. So you need SQL. But there are times where it's just not fast enough. So what we've done is we've given you these JSON API queries that are super tuned. For example, this first one, get records by IDs. I'm going to change the name to athlete. It looks up by the ID field in a table or by the primary key. You have several options. And I'm going to return 2 records 1 and 2. This bypasses all the layers of the SQL engine. So I returned records 1 and 2 here. So you can see them here. There's the Michael Jordan, where there's no I in team, but there is in win. One of my favorite sayings. And then here's Babe Ruth. Every strike brings me closer to the next home run. I love his tenacity. These guys, this is highly tuned queries. It knows exactly how to look them up. It bypasses all the layers of a SQL engine, gets you to the data, gets it back to you as fast as possible. This is so low latency. We have major customers in the world, like Verizon, for example, who use this exact. They purchased FairCom DB because of its guaranteed low latency to return the same data every time and again, just like DynamoDB would. So you get the power of DynamoDB's performance and consistently low latency queries with a SQL engine that is completely flexible that DynamoDB can't do, Mongo can't do. Right? They don't have that SQL engine, but you get the performance of DynamoDB, the flexibility of SQL, and the JSON that you would get in MongoDB, all in the same database. And this is not a hard API. Look at that. All I had to do is put in. I mean, anybody watching this, I could train my, I could train anybody to go put your name of your table here and put the ID numbers down here. This is so easy, right? That's how hard we've made this. We made this the most easy possible thing to use. Let's go switch to another highly tuned query. This is get records by index. This looks up data using the index, and you give it the index you want to use. Now remember that conditional index thing I talked about, where you could build hundreds of specialty indexes that answer the question already? All you have to do is put the name of that index here, and it will automatically return the answer to your question right out of the box at super high speed. At DynamoDB speed with consistent latency, bypassing the entire SQL engine, and faster. So you get DynamoDB performance on a solution as simple as, or even easier than MongoDB with your JSON, which is dang cool. So that's get records by index. And I'll just use the athlete table again here, change this out. All I did was, notice how JSON is just like filling out a form. Okay, what's the table name? Put the table name in there. Let me go run it. Boom, I get the answers back. And here it is by index. The other cool thing about indexes is they're sorted. So now if you get records by index, you're getting it in sorted order. SQL would have to look at the optimizer and go, oh, do I have an index that puts it in sorted order? Oh yeah, I've got one over here. Okay, let's plan on using that. Or SQL say, no, I don't. Let me go do a sort thing, and sort's really expensive. Here, you've got your index, it's sorted, and you can just get the job done. And if I want to get it back in reverse order, I just add a property called reverse order, and it'll return it in reverse order. Save time, I'll just keep moving on. We have partial key range, which means I could search for athletes. Let me just do that one. I'm going to search for athletes where I'm going to put I'll come back to the table filter in a second, but I'm going to use the name live past 2000 as my index, and I'm going to put a partial name on that. So I indexed by name, but I put a conditional ranking in my live past 2000 saying they had to live past the year 2000 to be in the index. So Babe Ruth won't show up. So let me return all the records that start with the letter M, because that's a partial key range. So here we go. Here's my records. I got Muhammad Ali and Michael Jordan in the results. Now, I also added a table filter. That's another cool feature built into the JSON API. The table filter is like a SQL where clause, but it's faster. And here's why. You've already chosen the technique you want to query the data. You've already chosen a non-SQL technique that bypasses all that complexity of the SQL engine. It's highly tuned and optimized for this exact purpose. Now you're going to add a table filter and say, of the results that I get back normally, as I encounter records that I'm returning to you, I'm going to filter them out if they don't match the query criteria. So anything here, in this case, if your ranking as an athlete is less than 4, you are included. But if your ranking is greater than 4 or 4 or greater, you're not included. So you can have table filters added to it in this highly tuned model. That gives you most of the power of SQL, except for joins, in the highly tuned API that's super fast. And Mongo doesn't have this. Couchbase doesn't have this. DynamoDB can't do this because DynamoDB can only look for things that are in its indexes. So DynamoDB's ability to do this is very limited. This gives you the power of beyond most NoSQL engines with a high performance against SQL or JSON data. So that's pretty cool. And also notice the data return was pre-filtered. I used this. We have a really cool way of including or excluding fields in a query. In this case, I use the included fields, but I could have just said, let's take this one out of there, and let's use the exclude. Sometimes you want everything but a field. So let's get all of the fields but the name field. And if I see, yep, let's run that. And now let's look at the data that came back. There we go. See, all the data came back with a whole bunch of other fields, but the name field's not in there. So it's really easy to choose what fields to return. And notice it's just easy JSON objects. There's nothing easier in programming. Here's another cool little secret about our product. You don't need a driver. Every other product you get, Mongo, Couchbase, all of them, you need a driver. You need some kind of code that you stick inside of your programming language to make it work. Because every programming language uses JSON, and every language has the ability to post over HTTP. You don't need a driver. You just simply post this JSON over HTTP and the results comes back. So now you can just, without a driver, it gets using the data right out of the box, which is really a game changer when you get down to it, because drivers or opinionated drivers don't work the way you want them to do half the time. If there's a bug in the driver, then you can't use it to do that feature against the database. Here, our API is your driver. You just use it. You can just copy and paste these JSON queries in your code and go. So I have a couple other specialized queries I won't bore you with, but we can get records by table, which is optimized to get the entire table's records at once. We have get records in a key range. You can take any index and say greater than M, less than M. We got getting records starting at a key, which is a great way to look up a record. And then from there, you can walk the data, which takes me to the last thing I wanted to share with you. We have a thing called cursors. So cursors, once you run one of these queries and you return a cursor, so I'm going to do that. I'm going to get a query. I'm going to get a cursor back from this athlete table. I'm going to query it. I'm going to start at a key, and the key is going to start where the player number is greater or equal to 10, and I'm using that special index, lived past 2000, and I'm saying the name has to be greater than or equal to, and I'm specifying the name field, and I'm specifying the letter P. So I'm going to start, probably get back Pele, who's in the database. So let's go do that. But I also say I'm going to turn return cursor true on it. So now I'm going to return a cursor. So I'm going to run this query. Did I get, this was my special query that told me I have a reverse order in here. Cursors have their own way to walk the data. Forward or backward. You don't need to walk the data forward or backward when you query it. All you're doing now when you return a cursor is you're setting up the query, and then you have total control of where you walk the data afterwards. And I don't need to skip records either. So I'm going to get rid of these extra properties. So notice my error message told me right away, oh yeah, you can't use return cursor with these other properties. Let's see, how did that do now? All right, it worked. So now I got a cursor ID. This long, ugly number is crypto random, just like our auth token, for security reasons, so people can't just guess your cursor ID. And my UI is going to remember this cursor ID, so I don't have to memorize it myself. But in your application, you would take this cursor ID and save it and reuse it. So now I'm going to run another query. I'm going to go over here to get records from cursor, and it's going to use that cursor ID here, and I'm going to go run the query and see what happens. Okay, so now it returned me one record, Michael Jordan. Cursor remembers where you are, so I'm going to run it again, and this time I will get no data. See, data is empty because I've just walked through all the data that the cursor had in it. But it allows me to paginate the data just by running the same cursor code over and over again until I run out of records. But I can go do all kinds of cool stuff. I can walk the data forwards and backwards. I can skip the data. I can fetch the data. So here, I'm going to start from before the first record. The cursor is still alive and healthy, so I'm going to get rid of the skip, and I'm going to say skip 0 from the very beginning, and I'm going to fetch 10 records just for the fun of it. If there are 10 records that match, and there's not, and I'm going to run that, and now I'm going to get some records. There's Michael Jordan, Pele, Wayne Gretzky. There's 3 people that matched my query criteria. Now, if I run this again, it'll always work because I got before first record. So it's moving the record pointer before the beginning. And if I keep running this thing, it's going to keep returning me the exact same records. But I could reverse that. I could say after last record and start at the end. Now, this is kind of a cool trick. After last record, and I can go skip back 4 records. So I'm going to go back 4 records and then return me 10 records. So I'm going to the end. I'm walking backwards 4, and I'm going to return up to 10 records. There's only 4 records there, so it can't return 10, but I will see what happens. This time it returned the records, and it gave me the last 4 records. I could also just do it again and shrink it down to say, give me the last 2 records. So now I've got down just one and only matched the criteria at the very end when I walked back 2 records. So you can walk forwards and backwards in your data. That is a really cool feature, and it's incredibly efficient because the database knows where you're at, and you don't have to pass in context. You don't have to write complex code. Just run this little thing over and over again and paginate through your data. You can tail the end of your data using techniques like I just showed you. You can walk from the beginning. You could look up a record in the middle and walk around forwards and backwards around it. You have complete flexibility to walk the data. That is a really fun, powerful feature that you will not get in MongoDB or Couchbase or DynamoDB. This is incredibly powerful and fast. You can also get records using SQL. So if you want to use SQL, I can just use SQL right here. And guess what? It's a JSON API. So what it's going to return the data as? JSON. So now I run a SQL statement, no errors. So I come over here and look at the data. It's the same JSON data we've been looking at, but SQL did it. So now just think, in your JSON API, you have all the power of SQL, get the data any way you want to do it. You have all the power of specialty queries that give you the specialty performance of DynamoDB and better performance than Mongo and Couchbase, all in one little simple API with just a few actions. That was easy. And anybody can do this. You don't need to be a specialized database expert, and you don't need to be a DBA to do this, and you don't need a DBA to run our product, because our database will self-tune itself and keep itself running. So you don't have to pay for a DBA. I think, do the math real quick. If you pay a $5,000 license to use a database server, and then you've got to pay a $250,000 person fee to go run the thing. Oh, by the way, it's not just one though. I need 2 because you have 24/7 support. So I got to buy 2 DBAs. Oh, $500,000. Okay, so $500,000 a year for a license if I'm just running one thing for around, $5,000, $10,000, $20,000, depending on how big the server is, or maybe $60,000 for a ginormous server, right? The DBA cost dwarfs the cost of the product. But you don't need one with FairCom DB. We were designed to work in lights out scenarios. So think of all the money you're going to save. And so FairCom DB gives you event streaming, gives you JSON and SQL over the same data at the same time, and it revolutionizes the entire industry because it's so easy to do all the above.